Hello and welcome to Unplugged, where we dive into the fascinating world of industrial automation and IoT. Before we jump into today's episode, we're going to do a quick shout out to our sponsor. This episode is made possible by Phoenix Contact PLCnext Technology. Phoenix Contact is reimagining SCADA with PLCnext, delivering HTML5 local visualization directly from the controller using PLCnext Engineer.
That's right, Phil. That means that there's live dashboards on panels, PCs, and smart devices without adding any unnecessary layers.
And because PLCnext is open by design, you can integrate high-level languages like C#, MATLAB, Simulink for advanced control, all running in real-time, secure industrial hardware. So let's get into the episode.
G'day, Phil. Anyway, everyone, welcome to our podcast. My name is Ed Fuentes. Today's guest is someone very interesting. Many will recognize them through LinkedIn, has a high following, who's known for his strong opinions, practical engineering, which we're going to hear about today, Phil, in his podcast, and designing systems that actually work. He's had a long time working with his father. We're going to hear more about his story, but it's quite an interesting guest, so we're very welcome, very happy to have Jason Watts join us. So thank you, Jason, very much for joining us today.
Well, I appreciate you for having me on. Thank you for inviting me.
Yeah, I guess we would start, just do a pretty quick introduction into who you are, who you work for, what's your company, where did you get started? Probably that's the first crux of it.
Yeah. So I kind of like to open up my YouTube live streams in the kind of all the same way of just, my name's Jason Watts. I'm the owner and founder of a little automation company out of Tuscaloosa, Alabama called Alpha Industrial Technologies. I am currently here in the Atlanta, Georgia area. And so some of the background noise and stuff, this is a shared warehouse space. And so you'll hear people actually doing work instead of just kind of talking about stuff. But yeah, so pardon the background noise for any of that. But yeah, so just a little bit about me. I had the opportunity. You kind of mentioned my father. He had a small integration outfit on the side. He spent about 38 years working at coal mining and just as a system designer, a controls engineer, and he worked his way up from inside labor at the very bottom, quite literally 2,000 feet at the bottom, all the way outside to doing all their capital projects and doing multi-billion-dollar kind of just total mine designs. And so on the sides, though, he always had kind of this integration outfit to where he would help around the Tuscaloosa, Alabama area. And so I started at a very young age helping him design panels or build panels, redo drives and things like that. I think my first Siemens drive that I helped him rebuild, I was 14 years old. Kind of the first electrical panel that I built was kind of around that same time, 13, 14. And ever since then, I've been working with Siemens systems, PLCs, HMIs, but mainly drives. I worked for a Siemens distributor, Wesco Distribution, for about a decade, and got a lot of experience just from them, just going around and helping other customers. And when you're kind of the point of contact for a European brand in the South, then a lot of people call on you, and it's not very well known, I guess, that the Southern United States has a lot of Siemens equipment in it because the Tuscaloosa, Alabama area has Mercedes-Benz has a manufacturing facility there to where they build all of their SUVs that are sold in the US are built out of Tuscaloosa. So there's a lot of industry there. And yeah, so I started when I was about 14 doing that. Built up about 25 years of experience now just working with Siemens automation and drives, and been doing Alpha full time for about 3 years now, I believe, maybe four. But we started Alpha in 2018 as a way for kind of to offer engineers the opportunity that my dad had. Because a lot of times you have your 9 to 5 job and that pays the bills, but maybe it's not quite as interesting because you're doing the same thing over and over again. maybe some fire drills here. You just don't really have a lot going on there. And so I started my company, Alpha Industrial Technologies, to be able to have projects and bring people on as they can work on the weekends, at nights, on projects that meet their skill sets. And so our company is designed around having people doing the things that they love, that they can do the best that they can do. And we just bring work to them basically.
So you're not in 9 to 5 sitting in the office. It's more whenever they're available.
Yeah. So one of the ways that we kind of go take our engineering to market is because we understand that, okay, we're going to be working with people that they're going to be doing the designs on their own time, going to be doing the design on the weekend. We have to take that into consideration. But one of the things that I learned early on about engineers is sometimes the best work that engineers do are on the weekends and after hours because it's stuff that they're involved with that they have passions about. And I had one of my best friends, he worked on a project that is just kind of amazing that everyone, it was all open source, all just done with nobody getting paid. But it was the first decentralized encrypted messenger service that has been used in various forms now to really protect a lot of people. They were a version of it was used in the Hong Kong protests in, I think that was around 2020, 2021 that was going through. And all of that was done just out of passion and amazing work that really changes a lot of worlds. Um, and so that was kind of the thing as we go to market. We say, okay, we know these guys are doing this on the weekend, but they're dedicating their passion to it. Um, and so, yeah, sometimes we might take a little bit longer, but we front load that so that we're realistic with our customers about, hey, we're not going to be able to do this in 2 weeks. It's going to take us five. But, and then we have our personnel that if we need to start it up, I'm going to be out there on site starting it up. Um, or someone else that we have some guys that are kind of doing their own 9 to 5 or kind of contract work type stuff, and they'll go out there and start up a piece of equipment in the same way. So, yeah, whoever has the ability to do the work, that's who we use.
It's amazing like what you can do when the pressure is off almost, right?
Mhm.
Like where you're in your own space, you can get into, I guess, a bit of a rhythm or, you know, yeah, like have your own safe space to really design code. I mean, there's this whole new, I guess not new, but I guess description of vibe coding, right? Like where you're actually in the zone and you keep going and, maybe you're using AI to help you along the way, but, that sense of like just real focus and drive kind of that's a really interesting point about how people operate in, on the weekends, after hours. I can definitely attest to doing my own projects and getting into the vibe and and being able to produce things that I wouldn't normally produce in your day to day as well. So yes, it's definitely interesting.
Yeah, we at Alpha, eh, I have this term that's called that's past Jason, and past Jason has always known much better what he's doing than present Jason. Because I'll go back and because of like being in that kind of in the zone, in flow state or whatever, and I'll be like, man, this is some good stuff. I have no idea what's going on here, but it's really good. And I'm like, oh yeah, that was me. Like I and I'll go through and like go to like add a feature and oh, I didn't even realize I had to added that feature back when I wrote it 2 years ago and and it's already there. And yeah, all because of like getting into the proper mode and giving people the right amount of time, the proper motivation. A lot of times motivation mismatch causes a lot of problems. And like if you're not connected with both the the reward and consequence of your programming. Sometimes that can be a little bit of a problem, but when it's properly done, it's really amazing, I do believe.
Well, just creating that environment, Jason, for people to um, know that when they have a spark of brilliance, of whatever time it is, whatever day it is, that's fine. That's great.
Mhm.
And you're flexible towards that. I'm assuming that's what happens, is that you're right. You're in that zone, you're in that place, and you just got to keep going, knowing that the company you work for or the people you work for understand that that's how it happens, and you give some time away during the other times when they can do other things, and just having that flexibility. Yeah, that's good. It's an interesting thought process.
Yeah. Yeah, and it's kind of a self-selecting process as well, if I have to admit, because you've most of the people that I'm working with are already kind of out there, get a lot of our connections from LinkedIn. And so we'll kind of like, all right, these guys are putting themselves out there. They're doing this kind of work. And um yeah, you just kind of get a feel for kind of like, I think I want to work with them, like I think you've actually have had someone on this podcast before that I've worked with, Gina, Brooks, Zach. They've I was in a class with them, and yeah, I was like, they know what they're talking about. They absolutely know what they're talking about. And yeah, we ended up doing some work together, and it's kind of this like I said, self-selecting. You have people that already are showing passion, and then you're just enabling them. And I rarely ever go out and kind of like put out like a job rec for someone. I'll find someone I want to do work with and be like, "Hey, let's find some work that you could do, and let's just kind of enable that." And like, it's kind of an accelerator program almost.
Absolutely. Yeah. It's really how those, I guess, relationships are developed, as well. We have a pretty big network now of audience, and getting the right people in the right rooms is critical for this. And like, we appreciate you coming on the show, right? That's part of the network as well, and everything that you contribute online as well. So it's all moving forward. Everyone's contributing to the industry, with innovation and sharing their knowledge, as well. I guess in terms of what you do in your day to day, I guess you know, with your PLC, I guess, background, is I guess, what kind of challenges do you see in the industry right now, or around design, code, those types of, I guess, operations in your day to day?
Yeah, well, I guess one of the things that I'm seeing just for small businesses particularly is this scaling problem, and it's nothing new. And there is a benefit to kind of the AI revolution of being able to kind of, I guess, not have to do everything every time. But I think it's pretty well documented among programmers and kind of like people that are in the industry that's kind of a a two-edged sword, and it can kind of cut both ways. And you could kind of get a little bit of a, what's the word, lax. You're kind of not quite thinking about things quite as hard, and you're taking things for granted and saying, okay, I'm going to assume this is going to work the way I expect it to work, when you're not necessarily guaranteed that. And we've had that throughout all of time, in terms of like, from a programming perspective of saying, yeah, there's going to be bugs, there's going to be things that aren't going to work right the first time, and we kind of get that into perspective. And so now that we're kind of, there's two groups of thoughts of like, you have managers and project managers for your customers that are wanting this AI integration, and you're like, what are you talking about? Like, what do you actually want? What do you mean? Um, because there's I use AI all the time to be able to kind of like talk through equations, work through things. If there's some simple scripts or stuff, I know we use it a lot, a lot of Ignition in our kind of workflow. And a lot of those basic scripts of like, hey, we're needing kind of this SQL this SQL query like done properly, like where you get back from that. Those little blocks and everything. Sure, we rely on that. But ultimately, at the end of the day, we're going through and we're integrating everything together and we're putting that together. And some customers are like, oh, well, you're using AI, so that means it shouldn't take you that long, or it shouldn't cost as much. And it's like, no, we're still going through and not cutting these corners. So I kind of feel a little bit of that as I'm going out and trying to get new business of like, okay, how do you use AI? And like kind of these questions that are coming through.
Yeah, you definitely have to focus on, the verification of AI, right? Like,
Yeah.
you can't just kinda let it lead you blindly into the abyss, I guess. You
Yep.
definitely have to have some strategy about the way that you can use it. So, I guess maybe you can share how do you use it then to help you iterate through? Like, do you do you, uh you're prompting and then re-prompting, like, what's the methodology around that?
So in my personal kind of workflow with AI is I use it as my adversary. And just from my experience in working through the years is if you get into where you don't know what you don't know, then you've got a blind spot there, and that's where your system's gonna fail, and that's where you're gonna end up getting someone hurt, or you're gonna lose production, like, something's gonna break. Like, all of these different things can happen because you don't have those kind of opposing viewpoints. And so, I my kind of production, like when I'm working on code, the way I have AI set up is to kind of basically nitpick and like second guess everything that I put in. And I'll go through and kind of like if it says something, I'm not going to take it as for like a matter of fact. I'm going to say prove it, and like where did you get that from? And a lot of the stuff that I'm working on is kind of the fundamental portions. Like for example, we're designing some dryer systems and kind of working with some thermodynamic equations. And I'm not a mechanical engineer or anything that's gone through and done those thermodynamic classes, but I understand the concepts and principles because I've worked with them before. And so in those workflows of like, hey, I'm trying to design these systems, like, why where is the problem gonna be? And I understand enough about it to know that, like, kind of a gut feeling of if I change this, this should be changing. I may not know exactly why, and then if that doesn't, like, go through, like, on the AI, it it comes across as like that. And then I'll just ask it like, how is this wrong? How is this system gonna break? Like, I've designed this. How is this thing gonna fail? What can you see that if you like the failure modes in the system? That's kind of how I use AI.
How do you differentiate things from what you should do in design and what you should do in code? I'm sure you would have walked into many factories or many places where you've come in and seen how things were done, and you have seem to have a philosophy how things should get built. How do you differentiate that?
Yeah, well, I mean, if I walk into a factory as kind of like an integrator coming into someone else's mess, trying to pick up the pieces, then like kind of hands are tied in that. But we do OEM work, and so we do design equipment mainly for the roofing industry. And in that process, we have you kind of run across like if you're in these silos, these engineering silos of where you have your mechanical engineers working over here and you have your electrical engineers over working over here, kind of control systems, kind of doing whatever. You have your software guys writing whatever, like on your HMIs. You end up there's assumptions that are made that like, oh, well, now my control system can't technically operate the way it needs to because you've designed this expecting the system to be under like not be able to perform properly. And we've designed the control system to where it would be able to rip what you've put in there apart. And it's like, oh, well, you don't need that safety factor. And I was like, you do because I'm accelerating it so fast that like it's gonna break. Um, and so coming into a plant I come from like a very a drives background, and kind of like all my YouTube content, or not all of it, most of my YouTube content is from kind of motion control and drives technologies and stuff like that. And one of the things that I'll always say is like you can't tune out a bad bearing.
Mm,
And if you have a system that isn't mechanically loading that bearing properly, then that's always going to be a problem. And there's no amount of control system that I can put in to change the fact that that's a problem. Um, and so if you're kind of coming into a plant at the end, I always hate going into a plant and being like, "Oh gosh, all of this sucks. Everything sucks." So like this is terrible. Like you nobody likes that guy. Uh, and so going into somewhere and being like, "Oh, here's the things that are good," and you can always find something that is good in a plant, even if it's just like the fact that the color of the floor that's like painted on the floor. Like you can always find something that's good. Um, and then going from there and trying to work from there. All right, what is actually good? How can we make that work better? Um, and and yeah, from a to me, if you're not looking at something from the end product and you're only looking at the individual components, there's always gonna be something that's not optimal. Um,
that's the skill of the magician. But put all things together. Yeah, you're right. They're not all in the same space where you want it to be. But yeah, you have to the skill of the engineer or the integrator. That's those midnight I suppose thought process that come through. Oh, I know how to fix this. Or I make it better. That's great. Is there sometimes though you walk into places and you see things going, wow, that's a different way of doing it. Wouldn't have done it that way. Have you seen any stories where you've sort of picked up something that you've learned along that journey that you've seen that
oh,
sort of stood out?
yeah, absolutely. I mean, there's some concepts that are just commonplace in some areas, and then it's like a total just new thing. And I'm like, and I guess one of the reasons why I got exposure to all of those is, at my time working for that Siemens distributor, I would go into so many different places and kind of get access to where not many people do. And like I've worked for 4 years at the coal mines, and in mining, everything is just tougher. Like everything has to be more heavy duty because literally the roof can fall in on it and it's expected to be able to like dig itself out,
Mm.
and just everything's hard there. And so what works in a coal mine is going to be more than overkill anywhere else. And like a steel mill, stuff that's like they're doing in a steel mill, you can take over into another industry. Like just one thing that we're looking at right now is how so in like a cupola of a steel mill, they need to actually detect the temperature of the actual product in that cupola. Well, they have very highly specified pyrometers in order to actually detect that from a distance. Well, there's all sorts of other uses for that thought process of tuning some sort of thermal imagery to a certain material out in other industries. Yeah, the stuff's expensive, but cost of downtime in some places is really expensive. So if you really need a a a good temperature, some of these solutions have already been solved. It's just a matter of like, are you willing to use someone else's technology? Are you using that's commonplace in one industry, and then it's new, yeah, here in maybe like a pellet mill for like a wood plant. Um, but kind of getting your customers accustomed to being like this is new to you. This is new to maybe this industry, but they've been doing this stuff for 30 years, out in this other industry.
Yeah, it's definitely um, when you visit customers that have kind of been doing what they're doing for so long, they don't really kind of, they're in their world, right? They're doing all the things to make their product or make their systems more efficient. But that's the value of, bringing a system integrator in to give them the wider picture, like give them best practice from the industry. I think that sometimes goes without saying, I guess, in those talks as well. So yeah, it's an interesting piece of the puzzle. I guess on those, when seeing, I guess some of those sites, is there some standout that you visited, some amazing plant that you saw?
Uh, I mean, the thing about it is like I've been in so many different places that have changed my perspective through the years. I think so. I had been around mining growing up, and this sounds kind of a little crazy, but they would have these kind of like health days or whatever to where it was basically just bring your kid out here to these places to where they can kind of get exposed to some of the stuff. It wasn't bring your kid to work because that would not be appropriate anyway. But uh so I kind of like seen equipment and everything, but it was always this like industrial, like really I don't know, like gritty, dirty, just like workman, blue collar sort of stuff. And so the first time that I actually went into that Mercedes-Benz plant and took a tour there and just realized I'm like, "Oh, this is different." This is a totally different thought process of like precision and kind of like timing. Hearing just about the just in time system of basically just having a door being built off site somewhere, a door panel like the electronics, and then it's showing up at the exact same time as like off the truck. They're unloading it and there's like it's like 5 doors down and it's coming off the truck. And that just kind of blew my mind that kind of the coordination that was available there because in coal mining, yeah, there's a lot of coordination, but the coordination is usually like with the really big hammer hitting the rock, and like that's it. Um, and kind of like all those pieces coming in like automotive. I also kind of impactful around that. It's like the stamping presses lines for the actual body panels, just the size of them, where you have like 6 or 7 3,000-ton presses, like pressing multiple passes and like all these things coordinating. Those are kind of some of the perspectives of, okay, the the cost of a mistake in one of those things is just astronomical. Just a little bit of a timing off on something and that press comes down and you ruin a $200,000 die. And then now you're out for that panel. You can't run that panel until you get a replacement die or to get it repaired. And that's the sort of stuff that's like really impactful on kind of a mindset approach.
Those sort of places, I suppose all at work, safety is quite important in that space because the coordination is one thing, but doing it safely is another thing. How have you seen that in mining? Is how do you see that in mining or the jobs you're seeing? Are you seeing safety becoming growing and being better towards improving production, while being part of the production process, being integrated into production, or into those sort of how are you seeing that roll out, especially from your history in mining?
Yeah, so from the mining standpoint, I guess, and it's not really just mining. There's
Mm,
kind of this, especially in the American market, that safety is going to impact production. And a lot of the things that I talk about is like, yeah, improperly designed safety systems when you don't really quite understand how things are supposed to be working, yeah, they are going to impact production. Um, but the importance of safety is and it's not just kind of like a production. So I like to tell one of the most, I guess, one of the most impactful machines that I've ever worked on is there's these mine hoists that are pulling all of the mines in Alabama. Well, not all of them. The ones that I worked at were all shaft mines. So the only way that you could actually get down into the mine was on these large like elevators and everything was on hoists. And these mines were 2,000 feet deep.
mm,
I'll say was, they are, they're still in operation. And they have these like huge hoists that are flying at a little over 2 minutes to get 25 tons of coal and then plus all the equipment out. And so in it's just basically going up and down and up and down on these ropes. They're metal ropes, but they're going over these pulley systems. And there were, I guess, there was one incident that kind of like not understanding the full scope of everything that had happened. Um, there there was a wet coal, and wet coal is more dense than dry coal. And it was raining, rain down in the shaft. There was all this moisture and everything, and it ended up filling up the actual, they call them skips. It filled up the skip with too much weight, and they were having to manually dig out the weight out of this skip down in the bottom. And now remember, this is 2,000 feet down, and they sit there and they're like, "Okay, we think that we've got enough out because we've measured it on the actual hoist and the weighing scales, and they're like, we think we can pull it out." And so as they were pulling it out, it gets almost all the way up to the top, and they forget that the drive itself is under a little bit more load, and it gets all the way up to the top, and they slow down, which causes the current to go up a little bit more, and then it faults out all the way up at the top. So you have this overloaded skip all the way up at the top, and everything worked exactly as it should, everything locked down, but because when it faulted, it was still moving up, it caused kind of that kind of like hopped up and then came down onto a locked brake. All of a sudden, those ropes slipped on the bull wheels, on the wheels that were holding them, and it started going down because it's just friction. And you lost all of your friction just because of that fault out on that just little bit of overcurrent, just a little bit too far, and just that little jerk, it slipped. And that, fortunately, they were able to, while this thing was falling 2,000 feet, was able to get everybody out, like yell on the radios for everybody at the bottom to get away. And they were able to get away, and because when it hit on the bottom, it was an explosion, just completely destroying everything on the bottom. Well, remember, you also have the other side of that pulley coming out the top, and it came out the top and destroyed everything on the top, and just unbelievable destruction, all caused by just a moment of just a little moment. And it wasn't really anything that was a mistake. It was just something that was, oh, we didn't quite expect it to happen like that. And that happened at a mine site that when I started working at those mines had already closed down. But that kind of like bad memory, because the mine was completely shut down for 6 months in order to repair everything. And when you're talking at the time, it was about $1,500 a minute downtime cost, then an incredible financial cost, and very fortunate to not have any, like, human cost. And so as I was going through and starting to work there, um, again, I did not actually work for my dad. My dad was up at the capital project level, like, he was at kind of the corporate level by the time that I had started working down at the grunt level. And but I had the opportunity my dad knew what I had been taught because he taught me, and so he actually sat there, and there was needs to be there was a need for changes to be made on this hoist. And he went through this detailed, just like, oh my goodness, it was every detailed checklist of every single thing. You have to change this thing because in the event, like this 5-layer deep of, if this possibility happens, then this will save you. And then, okay, normally this would rarely ever happen. So we have to change this other thing. And it was just like hundreds and hundreds and hundreds of just like like just thoughts that had gone through all of these different things that he did. And it was because of the cost of that, and like that like if I just one of them was just if you when you download, it takes longer for the processor to cycle through. There's a 1 sec there's like a cycle that takes a little bit longer, and you might miss a communication cycle between the drives. And there was a external watchdog circuit that was there that would trip out, and if that tripped out, it would lock the brakes. It
Mhm.
had and so if you did that while it was running, just not even thinking like, "Oh, okay, maybe you go online with the processor and it causes the processor to just kinda just jitter just a little bit," that watchdog would just lock up the brakes. And and so the first thing you had to do before you even got your cable out of the bag, like literally the programming cable could not be removed from the bag until you increase that watchdog on the mechanical timer. And so I took that thought process into everything. And on LinkedIn, you'll see kind of some like jokes I'll make about like kind of like modern day programmers. Like if you if you miss a variable or you program something wrong in Python, you might get a wrong answer. Well, if you in a PLC program, if you get a wrong calculation or you do something wrong, you might throw a Hyundai Elantra across a room because that's what the consequences are to some of these things. And I don't think until you've seen something as just I guess, so beyond comprehension of power, in terms of like, that was a 4,000 horsepower mine hoist that I was working on. The thing is literally taller than a building, like, the motors are just massive on it, and until you've witnessed some of that, you're like, doesn't quite sink into your head.
We
Yeah.
yeah, the 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 whole magnitude of these, I suppose, of product, and I suppose this is where it comes that nuance between making production go and not having safety interfere with production. Like you said before, safety is going to interfere with the production. And also these mine winders and these hoists, they would have been built for a certain work limit, a safe work limit, and production was always king. So let's keep pushing and pushing and pushing. And well, it can withstand 20, can it withstand 22? Can it do 25? And I've seen some machinery here that it was designed at a certain spec, but it make that spec. So let's just add more to the spec. Let's just make it go harder and faster. But to your point though, safety and all those other nuances that maybe weren't thought about before become quite critical. And the role of the safety specialist. I mean, and every time there's an upgrade, I imagine in the US as well, you have to do a risk assessment, go through the process again. What is, if you're going to change this, what safety procedures are in place for that thought process you mentioned? Is that how it works as well in the US for anything
Actually
you touch?
actually in the US, there's not that formalized process, and that's one
Mm,
of the things that's, like, I think it's moving towards, more of a formal process, like a risk assessment, because so when I started back at the in at Wesco, the electrical distributor, um, that was one of the things that I did. I was TV certified for, functional safety, and that was just kind of like, why wouldn't you do this? It doesn't cost you anything to identify the hazards on a machine and go through a process of like, hey, here is how we're going to kind of mitigate these risks. And in Europe, it's top down. It's from the machine directive, it's down. So it's law gets passed down into industry. Well, in the US, there are some laws. There are safety laws like, electrical code and kind of the fire code and, like, all these different things that are but in terms of changing safety for on machines, what's really driving that is insurance costs and liability for machines, and so if if I'm able to convince someone that, "Hey, here is a documented way that if you are getting sued because somebody did something or your equipment hurt someone or God forbid killed someone, um, here is a process that is already done, already laid out, that Europe has said this satisfies a good a good methodology for making a machine as safe as it can be, then why would you not do that? And you don't have to go through and kind of meet the highest standards on everything. And that's one of the things that, because this is so new into the kind of American designers mindset, and I say new, I mean it's been around for decades, but just in terms of like, hey, we have to design this way. We want to design with these methodologies. Sometimes that kind of old guard will come in and be like, "Oh, I just need to throw in some safety rated functions onto this, and that's how it is." And okay, I've got this risk, this cutting, clamping. All right, so I'm going to put a safety function on this motor, and it's going to be fine. Um, and that's one of the things that I kind of rant about on a lot of different things, of just saying like, sometimes doing the wrong thing, the wrong safety function, like STO, I absolutely hate STO, because the way it is implemented is usually less safe than if people would just leave it alone. Because STO is absolutely a safety rated function, but the function has to mitigate the risk. And only when you do a risk assessment can you actually say this function will mitigate this risk. Because a lot of times on an STO function, uh, like imagine you have that hoist. If you do an STO function on it, it's going to drop that load every time. And or if you have some sort of flywheel, and say you have a fan or something and somebody is about to get sucked into the fan and you hit the e-stop and it's an STO function, then you got to wait 5 minutes for the danger to go, because it's just sitting there like rotating. And and it's just because the function does not meet the actual hazard, because there hasn't been that risk assessment. That's when it can get really dangerous.
Yeah, you definitely have to have that overall picture in mind when you're looking at safety. You know, d does the safety measure meet the expectations of the risk, right?
Mhm.
Absolutely. I think I can't help not talk about this next topic because it's quite a big one, and I want to talk about, I guess, how you guys are turning poop into power and practical. Using that as a method of sustainability, I guess, as well. And so maybe you can give us a bit of talk about that particular project.
Yeah, absolutely. I love talking about poop.
Yeah.
Poop is on my mind all the time. And because, I mean, the thing about it is, if you can ever turn something that's normally a waste product into a profit stream, then that's what we need to be doing. And in the US, a lot of it is driven again by regulation that nobody really wants to do. But all you have to do is like just kind of in that same thing of like, safety can be profitable. Like, being responsible with your waste can also be profitable. And so what we're doing, the poop to profit, poop to power kind of like mindset, is we've been involved with a bunch of companies that work in the egg laying hen uh kind of industry. And in the US, it is kind of crazy. There are about 360 million birds in the US, egg laying birds, producing about 12 million tons of manure a year. And so what we have started doing is, at first it was like, okay, we're going to be taking this manure, and you don't want to put that manure directly onto a field. You don't want to just like dump it onto a field for all sorts of different reasons. This is very, very dangerous for the environment. So we come in and say, okay, we want to process it in a way that it can be considered fertilizer. So that's the first group of things that we were working on, these poop to fertilizer processes. Well, we've been kind of working with other companies using biodigesters to take in, before we actually produce that product, taking the some of the chemistry out of that, producing producing methane, producing natural gas to be able to be used either there on site as cogen, used in the drying process as natural gas for that drying process, um, or being sold actually onto the natural gas grid. In the US, California is buying renewable natural gas at kind of ridiculous rates, compared to kind of fossil fuels natural gas, and so there's this revenue and profit stream that's literally just sitting there in what's coming out of your birds anyway, and taking a burden and turning it into a profit stream.
Yeah, traditionally they would have, shipped it off to some, I guess, waste facility and it literally going into landfill or whatever. And now you're making, gold from from the
Yes.
from it. So that's a pretty interesting thing. I think biodigesters are like quite commonplace now. I think they're starting to get a foothold, that on-site power plant, especially from an agricultural point of view, you're already producing the waste. If you can leverage that by, charging vehicles or, especially all-terrain vehicles now, they usually battery or becoming more available in battery rather than fossil fuels. Um, and you're looking for, I guess, that way of offsetting some of those emissions that you're generally producing at agricultural facilities. This is definitely a way that you can start harvesting that power as well.
Are they centralized locations? Are they run them per factory? How small can these biodigesters be?
Well, so far, the projects that we've been kind of involved in are, um, more of these centralized to
Mhm.
where you're bringing the manure in from multiple houses and bringing it into a place, and one of the things that is dangerous with that is the cross contamination, bird flu, just all sorts of things that like it opens you up for. And so normally what you don't want to have your manure kind of coming from one house to another because it's just risky. So what we have been trying to do, and we there those projects are, if you have a million birds that you're feeding into a digester, then the economics kind of make a lot more sense. Um, we've been trying to find the lower limit of it and try to bring it down into that micro scale, because a little bit about my background is my ancestors were here in the US before, well before it was the US, in terms of just kind of like where they were coming immigration wise. And we were always on the frontier, and we didn't have the option of waste. We couldn't just like just throw away things that were valuable. As agriculture in the US got bigger and bigger and bigger and more centralized, more centralized, more centralized, you started realizing that there was a lot being lost in communities, in these local places. And kind of one of my personal goals as Alpha is trying to bring back to the smaller farms, bring back to the smaller chicken houses, the smaller farmers, bring them this technology that's like, where does it actually make sense? If you have 500,000 birds, does it work? Yeah, probably. Okay, how about 200,000 birds? Like, does that work? Okay, do you need to offset in from other streams? Like, and so that's where it's kind of the big technology is not the big projects, but bringing it down into the smaller projects.
The and you bring me memory of a friend I knew that had was developing. What's interesting about biodigesters is not so much the mechanics and the electrics from the control systems, but those tiny little bugs
Mhm.
that do all the work, converting that into gases. And he was working developing what he called superbugs. And they were taking this technology to prisons for waste. Same thing,
Mhm.
converting that waste, because, hundreds of prisoners, you get the picture, to provide energy back into the, well, I think, that gas to energy, to electricity to run it. prisons. So it's almost a self-contained system. I thought that's a brilliant idea. Same scenario. How do I make this as small as possible? And it was to do with superbugs. The better the bugs, and you have to look after the bugs because the bugs tend to, like you said, you got to make sure that they're fed correctly, fed well, and they'll do a good job. So how are you going in that journey? Are you managing to get down to that sort of smaller, compact size box?
Yeah, so we've brought it down into I've I took it down to the very smallest scale. So built a system around 55-gallon drums, essentially, and then tried to scale up using that. And I'll be honest with you, like the outputs of it isn't really well, but what you can do is you can kind of get this sort of system going, and as you get more material, more feedstock going into it, it's not very expensive to add on.
Right.
And so you can start scaling it up to where as long as you have a little bit of room, then it can scale up. And kind of like what you're talking about, the the bugs in there are pretty sensitive, and that's kind of the worst part of it. They're sensitive to the pH levels, they're sensitive to temperatures, they're sensitive to the composition of like the nutrient composition in the actual suspension. And so that's where automation comes back. A lot of these kind of like home scale digesters are just big big trash bags full of like watery crap. So, but that's kind of like what it is, and like taking that and taking these less expensive, kind of sensors, like pH sensors, temperature sensing, and bringing it into kind of this Industry 4.0, Internet of Things sort of like concept of, "Hey, we're gonna look at all of these individual things, and maybe we need to shift from one barrel over into another in order to balance these pHs out." And that's really kind of the design of what I've come up with is instead of having one massive system that's like one massive thing, you have these smaller cells. And then if one cell starts to have trouble, then you have all these other cells that are healthy to be able to kind of filter through and be able to balance things out. And that's all through automation and proper instrumentation and bringing that down to a scale, using less expensive sensors to, but are still able to detect. And that's where the future at that scale is just kind of the technology of the sensors.
Yeah.
We go back to AI. You mentioned AI before about helping through things. We've seen now some companies taking AI and putting all these variables into some sort of large, sort of what's called like a knowledge graph or some sort of matrix. And then the AI said, where are the relationships? Where can things go wrong? And letting it come back with some scenarios. And I imagine around those sort of bugs, where there's so many variables that can affect the bugs, affect how they produce and what's coming in. How can I determine what are the variables of what products coming in? And how can AI help me ensure that this light almost dynamically adapts based on what's coming through? So AI is definitely it's helping us, I think, in that space to understand the nuances of all the relationships between living organisms and what's coming in through the other side.
Absolutely. We actually have a a doctorate of or a PhD of artificial intelligence that's designing some neural networks for these systems for us. That's kind of part of our team. And that was one of the first things that kind of talking about that cross talk, being able to kind of bridge over that. I I understand enough. I understand pretty well about the design of these kind of machine learning AI systems like you're talking about that you're just connecting up multiple layers of nodes and different things and interconnecting inputs and having outputs and all of that. And then there's this black magic that goes on behind it, that it's just starts making connections and things behind it that I understand at a high level of that. And being able to communicate that to the engineer that is like, okay, here's how I want to actually design this neural network. And then say, what type of sensors, how do we need to connect this? What type of data, what type of input do we need? What type of formatting? Because just because you have a bunch of data doesn't mean that it's formatted in any way that's useful. And so a lot of this, the AI portion is just taking data from all over the place and just formatting into something that's useful. putting it on the same time scale, putting it into the same kind of like the same like actual data types itself, and just so that it can actually be weighted properly. So yeah, that definitely, and to me, I guess it was probably around 2017, 2018, NVIDIA came out with their first little self-driving car AI, and there was some neural networks out there, that some research that was really cool, but that was the first time that they were like, "We just kinda put this thing with a bunch of cameras out there, and we had to design a way to tell what it was actually doing." And when I saw that demonstration of that, I'm like, "Oh, we can use this at that point." Unfortunately, I didn't have like $100,000 to be able to invest in NVIDIA at that point, because I would be on a beach in the Dominican or something right now. Uh, but yeah.
I guess you mentioned Industry 4 and IoT and all these, I guess, methodologies. I guess on your learning journey, me and Ed are always on our learning journey. I guess, what are you focusing on for 2026 and beyond, I guess, in your learning journey?
Honestly, I mean, that's kinda nail on the head of this kind of like cleaning up the data and being able to present it properly to these machine learning neural networks. Um, because I have this kind of idea of a plant, so like a factory as a process, factory as a system. In a lot of these agriculture systems, you have a bunch of little systems that all work independently, and then you're passing the material from one stage to another. I see the holy grail of a system as being that entire plant operating as one organism almost, with one neural network that's making all of these decisions, because it is obviously cascaded. And so that's kind of the big thing for me, is how can I actually give a neural network the data that it needs to be able to actually do what it needs, or do what it needs to do in some sort of like process like that. And it's definitely pushing the limits of this 40-year-old brain, for sure. So, but that's one thing my dad, I'll talk about him for just a little bit. Uh, he is about to turn 70 years old, and his biggest fear is, like, him slowing down, like, mentally, not be because he's like, "I just can't." I could tell that I'm just slower, and I'm like, "You're not. You just wrote you just wrote a series of 6 books that, like, when you were, like, 65, that like, everybody that reads them is like, "Okay, this is just this huge knowledge," and he wrote it at age 65, and the reason he did it was because he retired, and he was bored, and he needed something to do, and so he was just started writing books. And I'm the same way. Like, you could see there's a bunch of stuff behind me that we're working on, like, um, have a dissected Delta picker that we designed on stream, that first time I go, I break parts on it because I didn't understand the kinematics. And so, but yeah, always learning, always trying to push something. And I, my wife is always asking me, she's like, when are you going to retire? I'm like, when do you think you'll retire? I'm like, the day I die, probably right after it, because always going to be doing something.
That's the joy of the industry we're in, Jason, and it's the fact that we see so many things that have been built, things that have been built, are being built, and the ones we're going to build. There's always something new, a new way of doing things, a new way of building things, and that's great. And technology keeps evolving. And I suppose, talking about technology, just before we wrap up, I want to thank again Phoenix Contact for supporting this episode of Unplugged.
Yeah, and just a reminder that Next Technology is giving engineers the freedom to rethink SCADA with their HTML5 visualization at the controller level, really giving them access to that front end visualization suite, and using high level languages.
Absolutely. It's very open, it's secure, and it's built for the real industrial environments.
Well, Jason, thanks for coming on and talking to us about the power of poop and and all of your experience. So we really appreciate your time and coming on the show today.
That's right.
I
And
appreciate it.
that's great. No, thank you very much, Jason. It's been excellent. And for all our listeners, everyone, please make sure you follow Jason's work. He's very easy to find on LinkedIn as Jason Watts, and check out his content. He loves a good question and looking for responses, and likes to challenge industry, as we all should be. We all want to get better and better at what we're doing and learning. So thanks very much for joining us and helping us to grow.
Yeah, and also check out his YouTube channel, right? As well with his live streams. And don't forget to subscribe to Unplugged and IoT podcast and also rate us 5 stars. But thanks, gentlemen, for a really great conversation.